Hello everyone, myself Rahul Subhash Kageri from Sri Venkateswara College of Engineering. Today I am going to take the subject mathematics. Subject code is BMATS 101. The topic is applications of polar coordinates. In application of coordinates, we gonna see definition, conversion between polar and rectangular coordinates. Third one is polar equations. Next one is finding areas of polar coordinates, calculating the length and slope of the polar coordinates, and applications where it is used. Definition of polar coordinates. Polar coordinates are the way of describing where something is located on a plane. They have two parts. Distance from the center of the plane is called radical coordinates. Second one is the angle between the reference line and the point is called the angular coordinate. This angle is measured in a special way called radians, which is like counting how many times you can wrap a string around a circle without overlapping it. Features of polar coordinates are the radical coordinates and angular coordinates. The radical coordinates tells how far away something is from the center of the plane, and the angular coordinate tells you what direction it is. Advantages of polar coordinates. The polar coordinates make it easy to describe the shapes around the circle. You can just give the radius of the circle and the angle where it starts. You can describe the whole shape of it. Conversion between the polar and rectangular coordinates. Polar to rectangular conversion. To convert polar coordinates into rectangles, x is equal to r cos theta and y is equal to r sin theta. Rectangular to polar conversion. To convert rectangular coordinates to polar coordinates, we use the equations r square is equal to x square plus y square and tan theta is equal to y by x. Graphing polar equations. Polar equations means plotting the points that satisfies the equation r theta is equal to f theta. Finding areas in polar coordinates. Conversion to rectangular coordinates. To find the areas inside a polar graph, we need to convert it into a rectangular coordinates. Then use standard area formulas. Polar curves. Areas of polar curve represented by r is equal to f theta is given by the formula. Third, practical applications. Finding areas in a polar coordinates is useful in determining the volumes, calculating the electric charges, and understanding the fluid dynamics. Calculating the length and slope in polar coordinates. The arc of polar curve can be calculated using the formula. Here r theta represents the radical distance as a function of angle theta, and alpha and beta represents the starting and ending angles of polar curve. Slope. The polar curve can be calculated using the formula dy by dx is equal to dy by d theta by dy by dx by d theta is equal to r dash sin theta plus r cos theta by r dash cos theta minus r sin theta. Here r dash represents the derivative of r with respect to theta and r represent the polar coordinates of the curve. Applications used in polar graph architects and engineering. Polar graphs can also be used to create a beautiful images designs like floral patterns. This graph represents the relationship between the angle theta and the distance from the origin, are resulting in symmetric visuals appearing shapes. Architecture Architects uses polar coordinates in designing structures that require curved walls and shapes like domes and arches. By using polar coordinates, architects can be accurately represent and construct complex geometric forms. Engineering. Engineering polar coordinates are used to study the stress and vibration patterns in bridges and other structures. By analyzing the polar coordinates of various points on the structure, engineers can better understand its behavior under different conditions. Thank you. Like, share, and subscribe.